We are going to discuss the representation of text in computer systems. To understand that, let's first talk about representing numbers. If you have a number like 34, it is stored as a sequence of bits. So it would be 1, 2, 4, 8, 16, 32. Sorry, it would be like 1, 0, 0, 0, 1, 0. This would be 30, 32, 34. Okay. The discussion of that is in one of the documents that I have posted. So this would contribute 32. This would contribute 2. So the whole thing would be 34. You know that computer memory is nothing but a bunch of zeros and ones. So it's an ocean of ones and zeros. Okay. Nothing else. It cannot store anything else. So to store numbers like 34, you have to use a sequence of bits like this. At this point in time, it is not important how you interpret this to be 34. That is not the point. The big point is that you have nothing but ones and zeros in your computer. So if you know that something is a number, there is a way to look at that sequence of ones and zeros and decide what its decimal value is, which is what we are all familiar with. So if you know that this is a number, you can actually see that this is actually going to contribute 2, this would be 16, and this would be 18, okay? Or if you know that this is representing a number, this would actually mean it is 7. There is a way to figure that out. You can read it from the readings. At this point, what you have to understand is that the computer memory is going to contain only ones and zeros. Those are the only two symbols available. That is an electronic machine, right? And you have to use the sequence of bits and convert that to a decimal number using a specific technique. So if you know that the 5 bits here are representing a number, it would be 16. If you found 100010, you would think of it as 34. If you found 011, you would think of it as 7. If you saw this would be thought of as 2. That is the first thing you have to understand. Okay, that takes care of numbers. There is a way to extend it to decimal number, the numbers with fractions. What about strings like your name, my name, the name of a town, such things? How do you represent that? Okay. How do you, if you have this memory and you only have ones and zeros to store even text, the address of a person, name of a person, how do you store, how do you store that? That is a puzzle. So we have to somehow interpret this sequence of bits as a piece of text. There is no escape from that. For that, let's first assume that we are told that this bunch of bits is actually text. Then how do you figure out what it is? Okay, for that, what we are going to do is treat a bunch of bits as a number. All right, we are going to do this in 2 stages. We will take sequence of bits, think of them as numbers initially. So maybe this, I don't know what this number is, I'm not going to compute. So take these numbers and then translate them into text. So let's see that for every alphabetic character, A, B, C, etc., there is a corresponding number associated. For every uppercase letter, there is a number associated. For every symbol, like the special characters like this, there is a number associated. For every letter of every alphabet, there is a corresponding number. So there is something called Unicode. Oops, excuse me. There's something called Unicode, which is used universally for translating between characters that you find in normal usage and numbers. So let's take a look at Wikipedia. This is one of the pages that I pulled from Wikipedia. This lists the Unicode characters, probably not all of them, but because it's going to be very expensive, very extensive, not expensive, extensive. So let's see here some things that are very familiar. The capital letter A has the number 65, I think. Let's make sure. Yeah, it's decimal 65. Okay. B is 66, C is 67. These are capital letters. Then lowercase letters should come here. Lowercase a is 97, B is 98, and so on. You can see these things like the left square bracket is 91, the caret symbol is 94, backslash is 92, and so on and so forth. So the greater than symbol is 62. So my point is that every character that you can find on this earth has a corresponding number. So if you are told that a piece of memory is containing text, you read out the numbers associated with them. And if you find, for example, 65 followed by 66, you know that we have A followed by B. Or if you find 60 followed by 69, then it would be less than followed by E. Let's, for the heck of it, see what the word Python will be represented by. Python, the first letter is P, but so it will be 80. The next letter is Y, so the next number would be 121. Then the next number would be 116 for T. Then H would be 104. Then O would be 111. And finally, N would be 110. So you will see these numbers. Of course, they would be, those numbers themselves would be ones and zeros. And once you know that the sequence of ones and zeros actually is a piece of text, you can pull the numbers out and then convert them to the letters or to the characters. That is how text is stored internally.